All right, this is the lesson for day 55, and it's May the 12th. This lesson is due on May the 18th. That would be next Monday, and not accepted after June the 1st. That's a long ways off, but you don't want to put these off. So we're going to continue with the lesson that we did yesterday, and what we're going to do is we're going to do some of these. Yesterday we just went one step. We went from, say, here to here, or from this box to this box. That's a one-step process. We're going to do two-step processes today, so I'll get into those in a minute. The first thing I'm asking you to do is figure out the molar mass. So I'm going to show you how to do that. So C2H4, and what you do is you write, I'll go ahead and do those over here in the margin. You have a carbon, so this says you have two carbons, and then you got to get the molar mass. And the molar mass of carbon is 12.01. So what you're trying to figure out is how much this molecule, this C2H4, weighs. And I'm going to allow you to just round these, so that's going to be 2 times 12. Sometimes I'm picky with students about having the decimals, but here it's okay. So that's 24. And then H4, hydrogens. It says that you have 4 of those. And each one, if you come over here to the periodic table, is 1. You can round that 1.01, but you round that to 1, and that equals 4. And if you add that together, you get 28 grams is the mass of 1 mole. So you can write that right here. All right, do the same thing for oxygen. Now be careful on this. O2. So you find an oxygen is 16, and you have 2 of them, that's 32. You don't multiply it by this number. This number you'll use in chemical reactions and when you're doing calculations, but you don't use that to compute the molar mass. This is 3 moles of O2. You want to know the mass of exactly 1 mole of O2 in each of these cases. You want to know 1 mole. So in this case, it would be 32. CO2, carbon, is 12. And it's got 2 oxygens. That's 16 plus 16 is 32. 12 plus 32 is 44. And finally, H2O, this is one, some of these you're going to use a lot, is 16 for the O, and each H is 1. So it's 1 plus 1 plus 16 is 18. Okay, so you need to have those. These are your translators. Remember, there we are right there. We live in the world of grams where we can measure the weight of a substance on a scale, but chemical equations are interested in matching up atoms and molecules or moles. Now, the coefficients, this is how many moles of each. I like to put a 1 even though it's not typically done. I like to put a 1 there to remind you that there is actually a number there. So what this is saying is you need 3 times as much oxygen, 3 times as many molecules of oxygen as you have molecules of C2H4 in order to make this reaction work to completion. And that'll give you 2 moles and 2 moles. Okay, so now we're ready to get started. So when I say these are 2 steps, let's see what that means. So let's do the first one. How many moles of H2O will be produced by 3.2 grams of C2H4? So over here I have C2H4, and down here is the grams row. That's something we can measure on a scale. And that's what we're given. We're given 3.2 grams. 3.2 grams. So it's grams in the grams row and C2H4 in the C2H4 column. Now it wants to know how many moles of H2O. So I come over here to H2O, and moles are the number of molecules. It's those big groups of 6.022 times 10 to the 23rd atoms or molecules. And so it means you have 2 batches of those, 2 big baskets of that many molecules. And it wants to know how many moles will this many grams of C2H4 give you. So it's a 2-step process. The first thing you have to do is get into the world of the chemical equation. That means you have to cross from here to here. And you have to get into moles of C2H4. Then from moles of C2H4, you need to jump across the equation to here to get moles of H2O. And that will give you your answer. Okay, so it's a 2-step process. So let's go ahead and write this out. So first of all, let's write the equation up here. So the equation is how many moles H2O. So I'm going to come way over here, and that's moles H2O. And we start off with 3.2 grams of C2H4. And you'll notice how far apart I'm writing them, because I'm going to have to put 2 conversions in there, and you may not even be sure how many you needed. So I'm going to have to convert from here to here, so that's my first box. And I can convert from here over to here, that's my second box. So it's a 2-step process. Okay, so to get from here to here, I need to use the molar mass conversion. 1 mole equals 28 grams. So down below, I'm going to write the 2 ratios. There's 1 mole, so unit of measure, and the substance, C2H4, for every 28 grams, C2H4, or okay, and we talked in the video yesterday of why you can do that. You can take this and either turn it into 1 mole C2H4 for every 28 grams of C2H4, or it's equally valid to say there's 28 grams of C2H4 for every 1 mole. But I need one of these 2 to go in that spot right there. Which one is it going to be? Well, here's the way you look at it. You start out with grams of C2H4, your answer is going to be in moles of H2O. So C2H4 has to disappear. So you're going to pick the one that makes C2H4 cancel, and that would be this one, because it has C2H4, gram C2H4 on the bottom. So we're going to pick that one. Okay, so grams of C2H4 cancels with grams of C2H4, and C2H4 is gone. Okay? So that takes care of that. We don't need to calculate what this is right now. We're just going to put it all together into one equation that's going to finally give us what we're looking for, which is moles of H2O. Now we need to go, we're in this world of moles of C2H4 because that's what's left standing here. So we go, that's moles of C2H4. We need to go from there to moles of H2O. So what's the relationship between this and this? Well, you just look at this number, these numbers here. There are 2 moles of H2O for every 1 mole of C2H4. So 1 mole C2H4 equals 2 moles H2O. So what you can do is write 2 ratios there. I'll draw a line between these. So I can write 1 mole, and you just use whatever the coefficients are as your number of moles. Okay, so you need one of these 2 ratios to go in that box. Which one do you need? Well, here you have moles of C2H4. You need that to cancel out. So you want to have that on the bottom, and you need moles of H2O to appear in the final answer, so you need that on the top. So the one you're going to pick is this one right here. Okay, not that one. So we come up here. Okay, and moles of C2H4 cancels with moles of C2H4, and moles of H2O is the last man standing, and that's what you want in your final answer. So that means you've got everything lined up properly. So now that you do, here's what you do. You multiply everything on the top, and then you divide by everything on the bottom. So it's 3.2 times 1 times 2 divided by 1 divided by 28. So you can just exactly punch in those buttons on the calculator. So 3.2 times 1 times 2 on the top, and now you divide by 1 on the bottom and divide by 28 on the bottom, and that gives 0.23. So the answer is 0.23 moles of water that you will obtain from 3.2 grams of C2H2. Okay? All right, so that's how you do that, and these are all done the same way. I'm going to do all of these except one. So let's move on to the next one. Okay, so B. The question is, how many grams of CO2 will be produced by 3.67 moles of C2H4? So let's start with what we're looking for. We're looking for grams. So we come down here to the grams row, and we look for CO2. There's CO2, so we want that box right there. And it's asking us how many, so that's a question mark. Now it says it's going to be produced by 3.67 moles of C2H4. So we come over to the moles row up here inside the chemical equation, and there's C2H4. So we write 3.67. Okay, so we need to get from here to here. How do we get there? You can't go outside of the chemical equation and jump between grams boxes like that. You can't convert from here to here and then across. You have to move sideways through the chemical equation. So you move from grams of C2H, excuse me, take that back. You move from moles of C2H4 to moles of CO2. So you move from here to here. And then you use the molar mass conversion. That's what this is. It converts from moles to mass in grams. Use the molar mass conversion to get you out to your final answer of grams of CO2. Okay, so let's start off with our question mark. We want to know how many grams of CO2. So we come way over here and we write unit of measure, grams, and what the substance is we're talking about, grams CO2. Okay, and over here on the left, you start with what you know on the left of an equation, and that's 3.67 moles, and I'm going to leave a lot of space between them. And it's moles of C2H4. So I can see how many steps this is going to take. It's going to take one step to get from there to there, and one step to get from there to there. So I'm going to draw two boxes because I'm going to need two conversions. Now see if you can figure out what the conversions will be, okay? You can pause the video if you would like. I'm just going to go ahead and do it. I'm going to do it silently and write quickly, and then we'll talk about it when I'm done, okay? Okay, so let's take a look at what we're doing. Try to keep everything on the screen at the same time here. And that's a little difficult when we get down to the bottom of the page. Okay, I think we're doing it just about there. All right, so the first thing is we need to go from moles of C2H4 to moles of CO2. So you can say there's 1 mole of C2H4 for every 2 moles of CO2, or you can say there's 2 moles of CO2 for every 1 mole of C2H4. So which one are you going to want in this box? Well, you start out with moles of C2H4, and that doesn't end up in your final answer. So you need that to go away. So you need that to go away. You need moles of C2H4 to go away. So you're going to pick this one. Okay, so it's going to be 2 mole. Okay, next, you need to do this. You need to go, you're now in this box, and you need to go down here. You need to get out back to grams. That's what you're looking for of CO2. So you use the molar mass conversion. So with that, you can either say there's 1 mole of CO2 for every 44 grams CO2, right there, or there's 44 grams of CO2 for every 1 mole of CO2. So which one do you want to use? Well, you need grams of CO2 to end up in your final answer. So you want to use the one with grams of CO2 up on the top. Okay, so we're going to pick this one. Now, sometimes a mistake that students make is it's not 2 moles of CO2. We use that for this conversion over here. It's simply this, 1 mole of CO2 for every 44 grams. Okay, so don't get confused by that number. So that's what I wrote down here, 44 grams of CO2 for every 1 mole. So we cancel at the beginning, go back to the beginning, cancel moles of C2H4 with moles of C2H4, moles of CO2 with moles of CO2. The only thing left is grams of CO2, which is what we want our final answer to be. So that means we have everything lined up properly. So now it's simply going to be 3.67 times 2 times 44 divided by 1 divided by 1. Okay? And that will give you your final answer. And that's 320, we'll call it 323 is close enough. Rounds up. Okay, so it's saying that 3.67 moles of C2H4 will produce 323 grams of CO2. All right, and that's your answer. Okay, we're going to do this, and I'm going to slide the other sheet over when we need it. Okay, so how many moles of O2? So right away I can come over here. We're kind of hopefully getting the hang of this. You're trying to find moles of O2. That's oxygen gas. Is required to produce 8.3 grams of CO2. So we're going to come way over here and write 8.3 grams of CO2. That's what you're given, and what you're trying to find goes over on the right. So if we look at this, grams of CO2, we're going to start with 8.3 right there. And we need to get to moles of O2. So that means we need to come up. Again, you can't go this way. You first need to go up into the chemical equation, and the chemical equation tells you the relationship between CO2 and O2. So you first come up through here using the molar mass, and then you move across to here using the relationship between the number of moles of CO2 to the number of moles of O2. All right, so this is where we're trying to land in this problem. So we start here, move to here, and move over to there. All right, so let's go ahead and write our ratios. The first one's going to be the molar mass of carbon dioxide, so I'll move this sheet off and write it way over here. Okay, so I didn't draw my boxes. Those are optional really, but they're just to give you, again, a kind of a visual of what you're trying to do. Okay, so I need one of these two ratios to be in that first box. And now the second box is going to relate 2 moles of CO2 to 3 moles of O2. Okay, one of these two ratios has to go in that box. So let's start figuring this out. Okay, grams of CO2 is what we start with. It's not in our final answer. That means we need it to disappear. So which one is going to make grams of CO2 cancel out? It's the one that has grams of CO2 on the bottom. So we're going to write this one over here. And grams of CO2 cancels with grams of CO2. Okay, now we need moles of CO2 to disappear and moles of O2 to appear on the top in the final answer. So which one of these two do we use? The answer would be this one. Okay, so what you're going to do is multiply 8.3 times 1 times 3 divided by 2 divided by 44. And that gives you 0.28 moles. So again, let's relate the equation back to the graphic organizer here. So you start with 8.3 grams of CO2. That's right there, grams of CO2. You use the molar mass conversion to get into moles of CO2. That's this right here. It relates a mole of CO2 to how many grams of CO2. And that gets you up into this box. And then you need to get from moles of CO2 to moles of O2. So that's this box right here. It relates moles of O2 to moles of CO2. And again, you have to pick the appropriate ratio so that the units cancel out properly. And I should have canceled moles of CO2, moles of CO2. So the only thing left at the end was moles of O2, which is what is in my final answer. Okay, hopefully these are starting to make a little bit of sense, especially using the graphic organizer. But the reason we don't stop here is because they may not make sense to you. And so we keep going, okay? Next question. I'm only going to do this one, and then I'm going to leave this one for you to do. It's marked A for some strange reason. I'm going to scratch this last one B, okay? Let me get on screen here. I scratched the very last question. I think this is enough. I'm going to do this one, and I want you to do this one on your own, okay? So here we go. Okay, so how many moles of O2, so I need to come way over here, and are required to make 12.52 grams of H2O. So way over here I have what I know, 12.52 grams. Okay, so let's come back to our organizer. we're starting with 12.52 grams of H2O. So here's the H2O column and here's the grams row. So it's 12.52 down here. And I'm trying to find out how many how many moles of O2 do I get out of that? So here's moles of O2 up here. There's the question mark. Okay, so you're going to start here. You always have to move into the equation first before you move sideways. So you move from 12.5 to moles of H2O using the molar mass conversion. And then you convert from moles of H2O over to moles of O2 using the relationship between 2 and 3. Okay, 2 moles of H2O, 3 moles of O2. So here we go. So I'm going to make two ratios out of this. Okay, and one of these two is going to go there. And now I'm sitting in this box right here. I need to convert to here. So it's 2 moles of H2O equals 3 moles of O2. Okay, so which one do I pick? Which one of these goes in there? Well, the way you judge is you have grams of H2O. That has to disappear because it's not in your final answer. So you need to make that cancel out. So you pick the one that has grams of H2O on the bottom. And those two cancel. Now you have moles of H2O left, and you need to get to moles of O2. So you have a relationship right here. Which one do you pick? You pick the one that makes moles of H2O cancel out and leaves moles of O2 up on the top. So that's going to be this one. Okay, so moles of H2O cancels moles of H2O. The last man standing is moles of O2, which is what you want because that's the one in your final answer. Now you multiply 12.52 times 1 times 3 divided by 2 divided by 18. And that will give you your final answer. And that's 1.04. Is your final answer. Okay, so I hope these are you're starting to get the hang of these. Again, I'm only asking you to do this one. It's asking how many grams of O2, so that's your question mark, and it's starting you off with 5.67 moles of H2O. Okay, do that one on your own. And I'll see you on the next video. Again, this is the video for Tuesday, May the 12th. And we'll see you on the next video.